Let's recall. So far, we have learned 5 logic connectives. The 5 logic connectives are negation, disjunction, conjunction, conditional, biconditional. I have a question here. Which one represent or? Between disjunction and conjunction, which one represents or? Disjunction, exactly. And conjunction represents and, right? Very good. So disjunction means or, conjunction is and. Very good. And the last class, we mainly focus on conditional. If we have a conditional statement P implies Q, can you tell me which one is the antecedent between the two pieces in a conditional P and Q? Which one is the antecedent and which one is the conditional? Which one is the consequent? Let me ask you, which one is the consequent? In a compound statement, conditional statement, P implies Q, or if P, then Q. Between P and Q, which one is the consequent? Exactly. Thank you, Ashlyn. Perfect. P is the antecedent, right? They have different names. P here, try not to use the arrowhead. P here is the antecedent. Q here is the consequent. All right. And we have learned the truth tables for negation, disjunction, conjunction, and conditional. Let's review. The truth table for negation has 2 cases as only. The first column is P. The second column is not P. Not P is the negation of P. If P is true, then its negation is false. When P is false, its negation is true. The statement P and its negation always have opposite truth values. All right? So that's negation. Very simple. I believe everybody understands this. Next one, disjunction. Let's do disjunction first. Let's see how do we determine the truth values for P or Q. Right side up V here, this notation is or, represents disjunction, means or, okay? In order to determine the truth value for P or Q, we need to know the truth values for P, truth values for Q. So this table has 3 columns. Since 2 simple statements are involved, we're going to have 4 cases. 1, 2, 3, 4. And the 4 cases are TT, TF, FT, FF. We always follow the same order. You should be very familiar with the 4 cases in this order. TT, TF, FT, FF. Okay. Do you guys remember I made you to memorize a sentence regarding the truth value of a disjunction? The sentence is, I'm going to type here, right? I'm going to type the sentence here. The only case in which a disjunction is false is when both pieces are false. The only case a disjunction is false is when both pieces are false. You're going to remember this sentence, all right? Look at our table. Only case 4, P and Q are both false, so the disjunction is false. In other 3 cases, T, T, T. Disjunction is very low maintenance, like easygoing, is easy to please. At least the one piece in the disjunction is true would make the disjunction be true. Only when both pieces are false, then, the disjunction is false. So that is about disjunction. Conjunction also has 3 columns in the table. In this table, we are going to determine the truth value for P and Q. The upside down V represents conjunction. It means and, the logical connective here. P and Q are the 2 pieces in a conjunction. We have 4 cases, 1, 2, 3, 4. And the 4 cases are T, 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 F, F, T, F, F. And knowing that we use capital letter, all right? I did see my students, some of them use lowercase letter, F, T, and sometimes their writing is not even clear. So this is T, and this is F. Look at those 2 symbols. Just you don't really, sometimes you even confuse yourself. So we use capital letters, FT, to be the truth values for statements. All right, use the capital letter, and less chance to mess it up. For a conjunction, remember the sentence I made you to memorize? Let me type here. Again, conjunction is and. The only case in which a conjunction is true is when both pieces are true. Conjunction is very high maintenance, like a princess, hard to please, right? In order for a conjunction to be true, both of them, both 2 pieces, both 2 parts in the conjunction have to be true. Even just the one part is false, the conjunction is not true. It's different from disjunction. See the difference between the 2 things. So in this table, the only case both 2 pieces PQ are true is the first case. When both P and Q are true, we have true. In other cases, since we do not have both true, the conjunction is false, false, false. All right? Yeah, we try to use an orderly and logically way to process the table. I really think the most efficient way to get it done is to memorize the sentence I told you. For example, the conjunction. The only case a conjunction is true is when both parts, like the part to the left and the part to the right, when both 2 parts are true. And you just need to find the case or cases in which both 2 parts are true. And in that case, the conjunction is true. In all other cases, you don't even have to think. They are just all false. All right? Conjunction, disjunction, negation, disjunction, conjunction. Now let's do conditional. Conditional is the new compound statement we learned last Wednesday, right? And the notation is P implies Q. The arrowhead, there's arrowhead in between the 2 parts in the conditional statement. And the part to the left, that is the antecedent. Yeah, I'll just write ANTE, antecedent. The part on the right is the consequent. They play different role. And we have 4 cases, 1, 2, 3, 4. You might remember the example that I gave you. Alice, Bobby, Cindy, and Danny, remember that? Pitiful Bobby studied very hard, 3 hours every day, but does not pass the class by the end of the semester. So in Bobby's case, the antecedent is true. Antecedent is true. Consequent is false. That means when the condition is met, it does not directly cause the consequent to occur. That means the conditional is false. And we can describe this as trust the friends forever, right? I mentioned this last class. Trust, hold on. Friends forever. Ideally, when we need to construct the truth table for a conditional, we want an antecedent here and a consequent here, and then the conditional. Follow the order. Antecedent, consequent in the next column, and then conditional in the next column. Then all we need to do is to look for TF, trust the friends, right? Trust the friends forever. And all other cases, T. Of course, all other cases, T, TF, TFF. Only the second case, the Bobby's case, when the antecedent is true but consequent is false, the conditional is false. In all other cases, the conditional is true. Let me type the sentence. You need to memorize, understand and memorize the sentence. The only case in which a conditional is false is when the antecedent is true, but the consequent is false. All right, one sentence for each compound statement, each type of compound statement. All right, next we're going to talk about biconditional. We're going to talk about biconditional. Let's construct the table. One, two, three. 1, 2, 3, 4. We're going to determine the truth value for the biconditional P if and only if. If and only if. F here means if and only if. Instead of just one arrowhead, if we have one arrowhead, that is conditional, right? But biconditional has a double arrowhead, both direction. We call the notation, the symbol, if and only if. P if and only if Q. The two pieces in the biconditional are PQ. P is here, Q is here. Since this biconditional involves two simple statements, we're going to have four cases as well. The four cases are T, F, T, F. All right? Now, how do we determine the truth value for a biconditional? I think the only case that might be a little bit challenging is the last case, case 4. Let's look at the first case, case 1. When both pieces P and Q are true, the biconditional is true. If you guess, you probably will guess this correct, right? If P is true, Q is true, P if and only if the biconditional is true, that's correct. The second case, if P is true, Q is false, and the biconditional definitely is false. Why? Because P if and only if Q means P implies Q, and at the same time Q implies P. In other words, P and Q are equivalent in logic. If P is true, then it will cause Q to be true. Vice versa, if Q is true, then it will cause P to be true. If you consider two statements, P and Q, one is true, the other is false. Think about the two statements. One is stating a fact, but the other is telling a lie. How is it possible for those two statements to be equivalent, right? So does that make sense? In this case, the biconditional is false, all right? Similarly, the third case is also false. P is a false, Q is a true. If the two statements do not have the same truth values, they are definitely not possible to be equivalent, right? So it's false. And the last case, as I said, this might be a little bit anti-intuitive. How about you guess? How about you guess? If P is false, Q is also false, what do you think the truth value of this biconditional should supposed to be? If P is telling a lie, Q is also telling a lie. Yeah, you got it right. Thank you, Ashlyn. It is true, okay? It is true. For some reason, there's a high rate people make a mistake on this part. P is false, Q is false, and the biconditional. Actually, the biconditional is true. Okay, if both of them telling lies, they are equivalent. Logically, truth value wise, they are equivalent. Like bad people be friends with bad people. That makes sense in reality, right? I sent you an email. Okay, thank you, Crystal. I'll look at it later. I noticed we have more participants joining us. Same with always, please send me an email, then I can fix your attendance. Thank you for coming though. We have, seems we have everybody, 16 participants. Okay, so the sentence we need to memorize about biconditional is, when both pieces have the same truth values, the biconditional is true. When the two pieces, PIEC, have different truth values, the biconditional is false. All right? When they have the same truth values, when the two pieces have the same truth values, logically, they are equivalent. They are, the biconditional is true. But when the two pieces have different truth values, the biconditional definitely is false. All right, so this is the truth table for a biconditional compound statement. You need to be very familiar with those 5 tables. Negation, let me write it down again. Negation, disjunction, remember the sentence you need to memorize for disjunction? The only case the disjunction is false when both pieces are false, right? Conjunction, the sentence you need to memorize, the only case in which a conjunction is true is when both pieces are true. Conditional, the only case conditional is false is when the antecedent is true, but the consequent is false. Biconditional, when the two pieces, the two parts, you know, on both sides of the biconditional symbol, when those two parts have the same truth values, the biconditional is true. When the two parts have different truth values, the biconditional is false. All right, so those are very important basics. Now I'm gonna talk about the level of dominance. Maybe we can consider a sentence, okay? Consider this sentence: I run 3 miles and I dance 3 hours. Apologize for the writing. When I type a lot, writing seems want to rush. I run 3 miles and I dance 3 hours. Oh, hold on. I run 3 hours, or I run 3 miles, or I dance 3 hours, and I eat a pizza All right. I run 3 miles, or I dance 3 hours, and I eat a pizza. That's a sentence. That is one sentence. What do you think about this sentence? What do you think about the grammar, the structure of this sentence? It has two connectives. One is or, the other is and. I run 3 miles, or I dance 3 hours, and I eat a pizza. If you guess, what do you think the person who say this statement wanted to express? If we let I run 3 miles as P, I dance 3 hours as Q, I eat a pizza as R, then we can translate this sentence as P or Q and R. However, the structure is not very clear, right? Do you think the person who said this actually means he either run or dance, after that, and he ate a pizza? What do you think? In this case, the parentheses is essential, is important. Parentheses here acts as a grouping symbol. In the frame, we frame P or Q, so that's going to be a piece. So the structure of this sentence right now is not confusing anymore. It is a conjunction. All right, it's a conjunction. It's about work out, and after that, eat a pizza. So it's a conjunction. So when we have more than one logical connectives in one compound statement, we must know the level or the order of the dominance. So let me show you in a note. Let me get a note quickly. This should be in 3.2. Let me see. Do I have 3.2 here? Right here. The order of dominance of the logic connectives is very essential when we construct truth tables for a compound statement. I'm going to show you this table right here. As you can see, negation has the lowest dominance. Biconditional has the highest level of dominance. Conditional is between conjunction, disjunction, and biconditional. So conditional is lower than biconditional, but is higher than conjunction, disjunction. Conjunction, disjunction have the same level of dominance. So when we have a statement, let's say a statement only involves conjunction, disjunction, we must use parentheses to clarify the structure of the statement. All right. Same thing if we have a P or Q and R. If we use the parentheses to frame Q and R, those two statements is different. All right. The one on the left is a conjunction. In the conjunction, we have two pieces. The first piece is inside the parentheses. Second piece is R. On the right, we have a disjunction. Okay. The disjunction has two pieces. The first piece is P. The second piece is whatever inside the parentheses. So the parentheses is very important when it comes to the structure of a compound statement. We use that to clarify the structure of statement. Okay, let me give you a little bit of time to memorize the order of the dominance. From left to the right, the level of dominance is increasing. If you look at those connectives from right to the left, the level of dominance is decreasing. Negation has the lowest level of dominance. Biconditional has the highest. Follow is conditional, and then conjunction, disjunction. Between conjunction and disjunction, there's no one is higher than the other. They have the same level of dominance. That's the reason if you have a statement only involve conjunction disjunction, you must use parentheses to clarify the structure. All right. Another thing I wanna mention is here. When expressed symbolically, parentheses are used to indicate which simple statements are grouped together. So parentheses is a grouping symbol. But when the statement, the compound statement, is expressed in words, we use a comma to indicate the groupings. We use comma, okay? Please remember this one. And when you work on your homework, when you see comma, you understand that actually means is a grouping symbol. So it means grouping. Let's practice some problem, okay? Let's practice some problem. It's been 5 days. Did we do those problems? Based on the syllabus, we're supposed to finish section 3.4 today. Section 3.3 and section 3.4 mainly focus on constructing truth tables for compound statements. Before that, we can just practice a little bit of translation. Does that mean we finished this one last time? Okay, let's do this one. Let the PQR represent the following simple statements. P says the temperature outside is freezing. Q says the heater is working. R says the house is cold. Write each compound statement in symbolic form. Read this one. If the temperature outside is freezing, comma, then the heater is working, comma, or the house is not cold. Okay. So what do you think? I see if then indicate a conditional statement. I also see or indicate a disjunction. So what do you think about the structure of this statement, common statement? If the temperature outside is freezing, then the heater is working or the house is not cold. I would say it's a conditional. If then. The part after if is the antecedent. The part after then is a consequent, right? Let's see, how do we express the blue part, the antecedent? The temperature outside is freezing. The temperature outside is freezing, so P, right? So that's the antecedent. The consequent is a disjunction, okay? The disjunction. So I can use a parenthesis. The disjunction has two pieces. The first piece, heater is working, Q. Second piece, house is not cold. House is cold is R, not cold is not R. By the way, if I remove the parentheses here, the structure of this statement is clear. It will not incur any confusion because conditional has the highest, we don't have biconditional. So conditional has a higher level of dominance. So we know this is conditional. And then to the right of the conditional symbol, we have a disjunction, right? And then negation has the lowest level of statement. So we don't even need to have a parenthesis. We know not R is just one part in the disjunction. Let's see the next one. The house is cold, comma, if and only if the temperature outside is freezing and the heater isn't working. And since we have a parenthesis, we have a comma here, comma if and only if. So this is a biconditional. Biconditional. The first piece in the biconditional is this part. And everything after if and only if, that's the second piece. Let me use a different color. Let's use green for that. Yellow is the first piece, green the second piece. So the yellow gonna go to the left, the green gonna go to the right, and then in the middle we have this biconditional symbol. House is cold. Okay, that is R. If and only if. On the right side, the temperature outside is freezing, and that is a conjunction. The conjunction has two pieces. Temperature outside is freezing, P. The heater isn't working. Heater is working is Q, not working is not Q. Without the parentheses, the structure will not, cause any confusion because of the level of dominance. I want you please see the structure. This is the biconditional. There are two pieces in the biconditional is yellow and green. The yellow is pretty simple, it's just R. The green itself is a compound. What type of compound? Conjunction, because it has and in it. And the two pieces in the conjunction are P and the negation of Q. All right, so even without the parentheses, without any grouping symbols, you should see the structure. Any questions so far? Okay, thank you. If not, I'm going to focus on constructing truth tables, all right? Let's get some problems from 3.3 and 3.4. 3.3 and 3.4. 3.3 does not have a conditional and a biconditional. And we can start from some very simple problems. How about let's do this one. Examples. Example 1. Construct truth table for negation, P and not Q. P and not Q. P and not Q. All right. Construct the truth table for this compound statement. Okay. I'm going to emphasize the importance of the structure of the compound statement again. So if you are a physician or nurse, you work in the health field, right? Work in a hospital and deal with the patients. Is that important for you to know an anatomy, like a human body structure? Very, very important, right? Especially when you need to do the operation to a patient, you're gonna know, where's the organs, where's the everything. So very, very important. If you are a architect, isn't that also important for you to see the structure of a building? That's basically all it's about, right? See the structure is two parts, right? And then you go inside the building. What's the structure inside? Same thing when we learn mathematics. It's also important to see the structure of an expression. You can understand the structure of the expression as grammar in English, right? When you take a Compo 1, Compo 2, when you learn English, you would have to learn the correct grammar. You have to be able to see the structure of a sentence. Same thing here is very important. Now let's look at our compound statement. We see a parenthesis, right? And the parenthesis is important. It's a grouping symbol. It groups whatever inside it. So you can see the whole thing here as one statement. That is one statement, one compound statement. And outside the parentheses, you have a negation. You are right. Negation has the lowest level of dominance. However, this one has a parenthesis. When the parentheses frame the pink part, and then with negation in front of the parentheses, the negation is negating the whole thing inside the parentheses. So basically the structure, if you look at the bigger picture, you are looking at the negation of the pink. Does that make sense? Is that clear? What's the structure of the compound? It's a negation of the pink, right? In order to know the truth value of this compound statement, which is a negation of the pink, we have to know the truth value of the pink, right? Yeah, and then it's like the outer structure of the building is a negation. And now you go inside the building, and you know inside the building you have a conjunction. That conjunction has two pieces, P and not Q. Yeah, you're gonna know, really important to see the structure. Okay, very good. Thank you, Jack. And then the way I construct truth table for compound statement is I start from top right corner. Okay, top right corner. I start from, you can do the same thing on your scratch paper. I'm gonna copy or write the compound statement we are given in the top right corner. So negation of the pink, right? P and not Q is the pink. As I mentioned earlier, in order to know the truth value of that negation, we have to know the truth value of the pink. Yeah, what's the truth value of the pink? The pink is P and not Q, right? But in order to know the truth value of the pink, we need to know the truth value of the two pieces. The two pieces are, the first piece is P, the second piece is not Q, right? And the two pieces determine the truth values of the two pieces determine the truth value of the conjunction. Right? And then the first two columns of the table are always PQ if the compound statement involves two simple statements. So that's how do I set up the structure for this table. And some of you might notice I'm going to label the columns. Okay, there's column 1, column 2, column 3, column 4, column 5, column 6. Yeah, some of you might already notice my column 1 and my column 3 are the same. Yes, sometimes you want to repeat or you want to have those repeating columns just to make your job easier. Because I want 3 and 4 together and right in front of 5, because 3 and 4 are the two pieces in the conjunction in 5. So sometimes, and it will not really burden you, all you need to do is to rewrite the column, just to copy the column. Okay, so since this compound statement only involves two simple, we're going to have 4 cases. 1, 2, 3, 4. Case 1, case 2, case 3, case 4. And the 4 cases in the first 2 columns, they are T, 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 F, F, T, F, F. I hope you get very familiar with those with the order TTTFF, You can quickly get it done. All right, now we just need to enter or fill in the blanks in the table, right? Column 3 is easy. Column 3 just copy column 1. T, T, F, F. Really will not burden you. Only will make your job easier later. Column 4, okay. Do you agree? Column 4 is a negation of column 2. Column 4 is a negation of column 2. So on your scratch paper, you want to write this down. Column 4 is a negation of column 2. If you don't have the yellow highlighter, like what I do here, I can do that very conveniently because I'm using a app, right? But if you are doing this on your scratch paper, what you can do is you can put your finger here, okay? Put your finger in column 2, and then another hand, your pencil gonna point to column 4. Your finger pointed to column 2. So when the truth value in column 2 is T, then the truth value in column 4 is going to be F, because column 4 is the negation of column 2, right? Do you see what I'm talking about? If you don't have the highlighter, if you cannot use the color scheme, use your finger, all right? So now it's easier, we can see. Let's only look at the 2 yellow columns. Let's only look at the 2 yellow columns. The 2 yellow columns are negation of each other, so they should have opposite truth values. When Q is T, negation of Q is false. When Q is F, there's T. When Q is T, this is F. When Q is F, this is T. Right? Look at the 2 yellow columns. Quickly double check. They should have opposite truth values because they are negation of each other. So far so good? And then you can erase the color. It might not be able to do that on your scratch paper. So try to figure out your own scheme. Try to figure out your own method. Now let's look at 5, column 5. Column 5 is a conjunction, right? And the 2 pieces in the conjunction are right in front of it, next to it, column 3 and column 4. So you can write column 5 is column 3 and column 4. Column 5 is a conjunction of column 3 and column 4. Ideal, right? This is ideal. Now you can, well, since I have the app, I can just color those 3 columns, right? Yeah, basically I'm doing a conjunction. The 2 pieces are column 3, column 4, and follow the conjunction as column 5. Do you guys remember the sentence that you need to memorize? I made you to memorize, recommend you memorize about conjunction. Conjunction is high maintenance, right? I'll give you a little time and look at the chat history. Which sentence is talking about conjunction? And read it aloud, then you can hear it yourself. Which sentence you need to memorize about conjunction? Did you find it? Right here, right? The only case in which a conjunction is true is when both pieces are true. So you need to memorize that. All right? So number 5 is a conjunction. Which case both 2 pieces are true? Oh, I see it here. Case 2, right? Case 2. Both pieces are true. T, T, T. And all other 3 cases not both true. So F, 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 and done. Very high efficient. Okay, now I can erase those colors. Yeah, I have number 5 done. Last step, we have one more column to do. Column 6 is a negation of column 5. I hope you see the connection. Column 6 is negation of column 5. You should see this before you even construct the table, right? I'm going to highlight the last two columns. Those two columns, they are negation of each other. Okay? Yeah, please take time to understand. Column 5, column 6, those two columns, they are negation of each other. They are negation of each other. Column 6 is negation of whatever inside the parentheses, negation of the pink, and column 5 is the pink. Okay, since the two yellow are negation of each other, they should have different truth values in each case. So case 1, pink is F, so negation of pink is going to be T, right? That is T, this is F, FT, FT. Double check is always helpful, and it won't take too much time, maybe just 2 seconds. FT, TF, FT, FT. All right, and done. We got it. And you can erase the color. Is this doable, guys? Is it doable? Okay, very good. And now I'm going to find another problem from 3.4. Let's do this one. P if and only if Q implies Q. Okay, I need to remember that. And example 2. Construct a truth table for P if and only Q implies Q. Let me double check. P if and only if Q implies Q. Okay, so this statement has a conditional and a biconditional, right? It's from section 3.4. And let's see, how do we construct truth table for this compound statement? And I need you to help me to identify the structure, to see the structure, like the bigger picture, the outside structure of the building. It is a biconditional or conditional. Is biconditional or conditional? Don't forget we have a parenthesis here. You know, without the parentheses, the interesting thing is, without the parentheses, this is a biconditional, because biconditional has a higher level of dominance than the conditional, right? Then the structure basically is this, right? P if and only if whatever that is. However, our compound statement has a parentheses. The parentheses is framing this part. That means that part is one whole thing, and that together is the antecedent of the conditional, and the Q here is a consequent. Do you see it? This is a use a different color. It's green. Do you see the structure? The conditional, yeah, this is not biconditional, it's a conditional. Is not contradicted or against the level of dominance because we have a parentheses. The biconditional is just one piece in the conditional because of the parentheses. All right, so this is the conditional with the blue part inside the parentheses as the antecedent and the green part as the consequent. I hope you see it. Perfect. It's very, very important. It's very, very important. Okay, let's construct the table. Same with earlier, I start from the top right corner. And, oh, I need more space. P if and only if Q inside the parentheses. implies Q. So that's our target statement, right? We need a construct table for that. Blue and green. My color scheme here is the antecedent is blue. Consequent is green. All right. So I want the antecedent here follow with the consequent and the condition. That's the ideal order. So I have a blue, green. Blue implies green. So the blue is antecedent P if and only if Q. The green is the consequent Q, right? Ideally, when we need to identify the truth value for a conditional, ideally we want to have the order like this. Antecedent, this column, follow with consequent here, and then the conditional, right? All right, so let's see the first two columns, PQ, like always. It involves two simple statements, so we have four cases. 1, 2, 3, 4. Case number 1, case number 2, case number 3, case number 4. T, 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 F, F, T, F, F. Okay. I wish that, this is a face-to-face class and I can ask you to help me and engage you better. It's hard because it's going to slow down the process. I hope you are paying attention, guys, all right? I'm going to label the columns just for convenience. 1, 2, 3, 4, 5. Let's fill in the blank. Let's do column 3. Column 3 is the biconditional of P and Q. So I'm going to color the first 3 columns. The first column is the first piece of the biconditional. Second column is second piece of the biconditional. And we actually covered this earlier today, right? For a biconditional to be true, the two pieces must have the same truth values. So this gives us T. This gives us T. Do not get confused. The last case, case 4, when both P and Q are false, the biconditional is true. When the two pieces have different truth values, the biconditional is false. So the yellow part, guys, the yellow part is exactly the same with here we learned today, earlier today, right? Exactly the same with this. That's the ideal order, P, Q, P if and only if Q. So now we have column 3 ready. Column 4 is the same with column 2. And you might wonder, why do you copy the ones? Because I want to order more convenient order. And this will not burden me. All I need to do is just rewrite column 4, right? Column 4 is exactly the same with column 2. If you want, you can color it and make sure you are copying the right column. Because sometimes you might see the wrong. P and Q sometimes look similar, right? T and F, of course, they are different, but sometimes you might confuse one with the other. So T, F, T, F. These two yellow columns, they are exactly the same. Just make sure they have the same thing, same truth values. Okay, almost. One more. Column 5. Column 5 is a conditional with column 3 as the antecedent, column 4 as the consequent. And we do have the ideal order. 5 is 3 implies 4. So this is the antecedent. This is the consequent. This is the conditional, right? All right. So we can see, do we have a trust friends? Oh, we do. The last one, right? Trust the friends forever. The only case a conditional is false is when the antecedent, This is antecedent. This is antecedent. Antecedent is true, but the consequence is false. And that's the last case, right? Antecedent is true, consequence false. So the conditional is false. All other three cases, TTT. And done. You see that? Yeah, we want the antecedent here follow by the consequent and then follow by the conditional. Then we can look for trust the friends forever. If we do not have a trust the friends, then we do not have forever. Does that help, guys? Any questions? All right, very good. Let's do one more, and let's pick a very complicated one. Let's do this one. Wow, this one is very complicated, right? Okay, let's try this. Let me do it again. We have 20 minutes. I hope the 20 minutes is enough to do this one. Oh, perfect. Awesome. Very good. Thank you for your positive response. All right, let's see structure of this common statement. Let's see the structure of this common statement. What do you see? Do you see a negation, disjunction, conjunction, conditional, or biconditional? What do you see? Those parentheses, brackets matter. They are grouping symbols. What do you think? Blue, pink. How about pink? Do you agree? This statement, very complicated one, is a conditional. Is blue implies pink. The blue is the antecedent. The pink is the consequent. Do you agree, guys? This is antecedent. Antecedent. How about I just write a antecedent? And this is a consequent. I just write CONS. Blue is antecedent. Pink is consequent. Can you explain it a little? Okay, that's a good question. So it has grouping symbol, right? The bracket frame the whole blue part. So that you just see that as the one whole thing. See this as one whole thing because the bracket is a grouping symbol. So this is one group. And this pink is framed by a set of parentheses. So this is a one part. And the structure of this statement is the pink implies pink. My bad, sorry. Blue implies pink. Blue implies pink is a conditional. In the blue is very complicated, but doesn't matter because the whole thing is inside a bracket. It is just one part of the conditional. The whole thing in the bracket is the antecedent. The whole thing in the pink part, the whole pink part in the parentheses, that is a consequent. That's it. Okay, perfect. So the last column we're gonna have, since I have the color scheme to take advantage, I'll just do blue implies pink. Otherwise, I have to copy the whole statement, right? Allow me to do this. So blue implies pink. So since it's a conditional, I would like to have the blue here. Blue is the antecedent. Blue follow with the consequent and then the conditional, right? So that's my ideal. Yeah, but the blue, I need a more work here. The blue here is a conjunction, right? Conjunction. Conjunction of P implies Q. Q implies R. Wow, that is a pretty complicated, right? Yeah, pretty complicated. So, and the pink is not R implies not P. Okay, so I'm gonna do this. I'm gonna copy the pink here again. Not R implies not P. And then add 2 columns. And this one is not R. This one is not P. Okay. And for the blue, I'm gonna put the blue here. Copy the blue here again. P implies Q. And oh, I think I can do this. I can do P implies Q implies R here, and P implies Q here, right? Yeah, I'll explain in a moment. And so those would do the pink, those two would do the pink, and those two would do the blue. And I need more space. How do I go this? Let's see if I can do this. Yeah, move a little bit forward. So the first 3 columns, 1, 2, it's going to be PQR, all right? PQR. Because there are 3 simple statements involved. Oops, there are 3. All right, so, okay. Since there are 3 simple statements involved, we're going to have 8 cases. How do we know 8 cases? Let me show you by using fundamental counting principle. P, Q, R. Fundamental counting principle. Remember this name, all right? And our task here is to assign truth values for the 3 statements. Let's do P first. We have 2 options to assign a truth value for P, either true or false, right? For Q, same thing, either true or false. R, the same thing, true or false. Multiply them together. We have 8 different combinations of the truth values of the 3 simple statements. So we have 8 cases. 1, 2, oops, 3 is not very perfect. I'm trying, okay? I wish I had a ruler, can make it better. So this is 1, 2, 3, 4, another 4. 5, 6, 7, 8. Okay. And we can also label. I need to move to this part a little bit more. Okay. Never mind. Just follow the water, okay? And let me show you how to write the 8 cases. The first 4 cases, you see PQ, right? And you should be familiar with the order T, 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 F, F, T, F, F. You do the same thing for the last 4 cases. You do the same thing. T, 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 F, F, T, F, F. Basically, you do 2 sets, all right? 2 sets, T, 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 F, F, T, F, F. And again, T, 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 F, F, T, F, F. And then for the R, you're going to do T, 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 N, F, 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 F. So we have all the 8 different cases. None of them are the same. All right? So let me label those columns. Column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, a lot. Okay. Look at column 4. Look at column 4. Do you see column 4 is a conditional with antecedent column 1 and consequent column 2? So now we are looking at column 1, column 2, and column 4, right? And so column 1 is the antecedent, column 2 is the consequent. You want to look for trusted friends. You want to look for the case in which the antecedent is true but consequent is false. Let's see, do we have that? Trusted friends forever. Trusted friends. Trusted friends. Trusted friends forever. All right? Trusted friends forever. And all other cases, T, 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 T. They are all T. Sorry about this, too big. Let's see if I can do this. Can make it smaller. Do you actually see it? Column 1, column 2, column 4. We do have trusted friends in case 2 and case 5. Oh no, case 6. Right? Trusted friends forever. Some response, please. I don't want to lose you. It's hard, it's too big. I haven't picked a question very complicated. All right, very good. And next column, number 5. Number 5, also a conditional, but the antecedent is Q. Consequent is R. So in this case, we're going to highlight column 2 and column 3. All right. Mainly, we are looking for trusted friends. Trusted friends. Okay. Do we have trusted friends? I see it. This is trusted friends forever. This one, trusted friends forever. And then no, 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 no. Trust friends forever. No. Trust friends forever. No. Okay. So only those 2 cases, trust friends forever. So we have T, 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 T. Okay, double check, double check. Column 5 has antecedent column 2, consequent column 3. So we are looking for trusted friends forever. Okay, trusted friends forever. Other cases are not trusted friends forever. They are not. Okay, that's it. And column 6 is easy. Column 6 is just the negation of column 3, right? So let me color column 3, negation. And we can do the negation of R. So the negation for R, column 6, when the yellow, look at the yellow column. When R is T, F, 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 F. And then we do T, 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 T. So compare those two columns, column 3 and column 6, make sure they have different truth values. Okay, very good. And the column 7 is a negation of column 1. So I'm color yellow highlight column 1 because we are going to negate column 1 and write it in column 7. Okay. Column 7, so when P is T, F, F. When P is F, T, T. When the yellow is T, this is F. When yellow is T, this is F. When yellow is F, this is T. This is T. Right? And we get that column done. And column 8. Okay, now we're done with column 1. I'm gonna remove the color highlighting. Now let's look at the column 8. Column 8 is a conditional, right? With antecedent 6, consequent 7, and we have the perfect ideal order. Column 8 is column 6 implies column 7. Column 6 is the antecedent, column 7 is the consequent, column A is the conditional statement we are talking about. So I'm going to highlight those 3 columns. That's the order we want, right? And let's see, do we have a trust friends forever? Nope, nope, nope. Trust friends, okay, here. Trust friends forever. Oh, another one, trust friends forever. And let me double check. We have 2 trust friends forever, and all other cases not. So they have T, 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 right? So we get the number 8, done. Number 9, let me erase the highlighting. Column 9 is a conjunction. Column 9 is column 4 conjunction column 5. A little bit far away. Column 4 and column 5. Yeah, a little bit far away. So I'm going to highlight them in yellow, 4 and 5. We want to see the conjunction of the 2 columns, right? Remember the sentence for conjunction? The only case a conjunction is true is when both pieces are true, right? So we are looking for both true in column 4 and 5. Case 1, both true. Case 2, not. Case 3, both true. Case 4, yes. Case next one, no. No. Not both true. Both true. Okay? Yeah, double check. Just make sure we do not make any mistake. The last case, true, true, true. And this one is not. This one is true. And this one is also true. And this one is true. This one is false. Okay. And column 10. Column 10 is a conditional. Let me erase those. Bear with me if I have to extend the class a little bit longer. Column 10 is conditional. It is not R. 6 implies not P. Not P is 7. Okay? 6 implies 7. Oh, you know what? We got a number 8. We got a number 10 already. Number 10 is the same with number 8. We got it already. Perfect. Number 10 is the same with number 8. Right? We got it already. So we just need to copy it. Number 8. So we have T, 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 T. Number 8. Okay, I need to color it and I don't miss which column. This one. And just copy exactly it is. F, F, T, T. Right? Number 8. We got a number 8 already. F, F, T, T. And they're all okay, very good. Almost done. Okay, almost done. The last column is conditional. Conditional. With number 9 as the antecedent, number 10 as the consequent, right? So we're looking for trust friends. We're looking for trust friends. Trust friends. Do we have trust friends, everybody? Not. We don't have trust friends, so everybody T. All right. So the last column turns out the given common statement is true in all cases. Yeah, in all cases. And we have a name for that. Let me show you the name. It's called tautology. Let me find a definition. Should be in 3.4. Definition for tautology. Yeah, right here. Tautology is a common statement that is always true. In our case, our common statement is a tautology because it's true in all cases, right? And then we also have to know what is self-contradiction. Self-contradiction is a common statement that is false in all cases. And the implication is just a conditional tautology. It is a type of tautology, but it is conditional as well. Okay, so I apologize. The plan of this table is not the best because I make the table too big that you lose the whole picture. Let me see if I can. Oh, this is better, right? This is better. Basically, you have all the rows and the columns. All right, that's our section 3.3 and 3.4. Next class, we're going to learn 3.7. And I'll see you guys. I'll see Essential in 10 minutes and see the rest of the class on Wednesday. Bye-bye. See you in 10.